Hi, today we are starting a new chapter and that is oscillations, which is included in your first module. Oscillation is a sort of movement, or we can say that it is a kind of motion, and that what the word motion, which we are familiar, right? Yes, motion means the displacement of something with respect to time. So in this picture, it is very clear. Initially, the girl was at a position x0. And after a time interval, after a time t1, the girl reached another position x1, and after a final time t final, the girl is reached to the final position. So we can say that I already told you motion means change in position with respect to time. So we can say that in a time dt, the girl is displaced a distance dx. So this displacement is with respect to this time, which is known as motion. Okay. And there are different types of motion. Linear motion is there. As you already saw, this is a linear motion. Okay. The motion is along one particular side. So it is a linear motion. And we have rotational motion. We have vibrational motion. A number of different types of motion are there. And you already studied that in your higher secondary classes. Now, suppose consider the movement of Earth around Sun. Okay, suppose this is our reference point and Earth is rotating around Sun. Okay, so you can see that this Earth is rotating around Sun, and you can observe that after a period of 365 days, the same motion is getting repeated. That is what we called a year. Once the Earth is completing a full rotation, 365 days, the same thing will be repeated. Okay? And this process is continuously happening. Similar to it, suppose we have a body which is moving in such a way that after a fixed time interval, it repeats. Okay? Similar to the case of the Earth and the Sun. Earth is rotating the Sun. So, suppose we have a reference point, we can see that after every 365 days, Earth is crossing that particular reference point. Okay. Similar to that, suppose we have a body which is repeating its motion in a particular interval of time. So in this case of Earth Sun, we can say that the particular interval is 365 days. So if the period of fixed, that is the 365 days is fixed. In that 365 days, Earth is again crossing the particular reference point. If the period is fixed and the motion is repeating, then it is said to be a periodic motion. That is, by definition, a periodic motion which is repeat itself after a fixed interval of time. And this fixed interval is known as the time period. Okay, that fixed interval is known as time period. So in periodic motion, then there are different types of classifications are there, and one among that is oscillations. So before discussing about the oscillations, why we are studying oscillations? Because you are engineering students, why we are studying oscillations? So this vibrational study, which is an unavoidable part of engineering. So while designing some machine or some building, the vibrational studies are important. You can see some real life example like shock absorbers. Shock absorber is an application of this particular oscillation. I hope you all heard about resonance. The resonance is also playing an important role in engineering and design. Acoustics, communication and electromagnetism, in every areas, the oscillation is playing a very oscillation, and the resonance is an important parameter. Okay, that's why we are studying the fundamentals of oscillations in your engineering physics. So I told you oscillation is a periodic motion. It is not just a periodic motion. Okay, so in the case of oscillation, it is a to and fro movement. We can say that oscillation is a to and fro movement about a mean position. In the case of a simple pendulum experiment, you can see that the simple pendulum is oscillating with respect to a particular point. Okay, so that is oscillatory motion. Or we can define the oscillatory motion. There are two conditions. The first condition is is it should repeat in fixed period of time. There should be a time period. The second condition is the body should move in both the direction, the forward and backward direction, to and from motion. Okay, the first condition is it should repeat in fixed period of time. The second condition is the body should move in both the directions. Then it is said to be an oscillatory motion. So in this chapter, we are mainly discussing about the harmonic oscillators. So the harmonic oscillator, which is a system that displaced from equilibrium position, that is mean position, and it is experiencing a restoring force which is proportional to the displacement. In the case of simple pendulum, so there is a restoring force acting on that simple pendulum, and that force is proportional to the displacement. Okay, that is a harmonic oscillator. So in the case of a harmonic oscillator, the first two conditions are both the direction. The body should move both the direction, and the second one is it should repeat in fixed period of time. The third one is the restoring force acting on the body, which should be proportional to the displacement. Okay, these are the three conditions of an oscillatory motion. And in this chapter, we have three types of oscillations. One is a free oscillation, the second one is a damped oscillation, and the third one is a forced oscillation. Okay, so in this chapter, we have three different types of oscillations. The first one is a free harmonic oscillation. So as you can see in this picture, the free harmonic oscillation is an ideal case. Okay, that is an ideal case because once the oscillator is given some kind of energy, suppose we are giving some kind of energy, it will start oscillating. But there will not be any external force acting on the body. We know that we all are experiencing a common force which is known as gravitational force. So with the presence of that force, we cannot observe a free harmonic oscillation. So in the case of a free harmonic oscillator, once the body starts oscillating, it will oscillate with its natural frequency. Okay, without any external force acting on the body. That is, once the oscillation is getting started, it will never stop the oscillation. It doesn't have any energy loss. If the energy is not decreasing, it will never stop its oscillation. So it is an infinitely repeating process. That oscillation will repeat for an infinite period of time. The amplitude of the oscillations will be constant. Okay. The second one is a damped harmonic oscillation. So as you can see in this picture, once the spring starts oscillating, after a particular time it is coming back to rest position. Why? Because there is a restoring force as well as a damping force acting on the arrangement. It is experiencing an external resistive force. Okay, so it will lose its energy gradually, and gradually its amplitude will become zero and it will come back to rest. That is a damped harmonic oscillation. Okay, the first one was free harmonic oscillation that will repeat for an infinite period of time since there is no external resistive force acting on it. The second one is a damped harmonic oscillation. There is an external resistive force acting on it. So after a particular period of time, it will lose its entire energy and its amplitude will become zero and there will not be any oscillation. The third one is a forced harmonic oscillation. In the case of a forced harmonic oscillator, the forced harmonic oscillator is a damped harmonic oscillator plus an external energy. That external energy is that man who is standing behind, who is pushing that girl. Okay, so that is an external energy. That is, unless and until we are supplying some kind of energy, it is impossible to maintain the amplitude of the oscillation. Okay, so in the case of a forced harmonic oscillation, in order to maintain that constant amplitude, we will give some external energy. Once we stop giving that external energy, gradually that amplitude decays to zero. Okay, these are the three types of oscillations. This is what we are going to study in detail in this entire chapter. The first one is a free oscillation. That is, it is an ideal case. There is no forces acting on the body. Once the body starts to oscillate, it will continuous infinite period of time. The amplitude will be always constant. The second one is the that what we experience because we are in a gravitational force. So what happens? There is an external resistive force acting on the body. So it will lose its energy gradually. That means after a particular period of time, its amplitude decays to zero. Okay. Example is simple pendulum is an example. The third one is a forced harmonic oscillator. That is, we are giving some external energy so that we can maintain the amplitude of the oscillation. Okay. Once we stop giving that external energy, in that case also its amplitude gradually decreases to zero and there won't be any oscillation. Okay. These are the introduction about the harmonic oscillation. I hope you understood the concept. Okay. This is what we are going in detail in coming videos. Okay. Thank you.